Okay, here's a piece of paper, right? I'm going to draw what you interpret your model as. And basically, you drew the Earth, right? There's the Earth. Now, you drew Polaris as that. That is not nearly as far as Polaris is from Earth, and not nearly as large. But let's, for the sake of this, just explain what you said. You're at the North Pole, alright? You look directly up, there's Polaris. Now, let's say you're there, or there, or there, or there. Now, with your logic, you were saying that if you looked straight up, or I guess straight north, standing at the equator, you would miss Polaris. Which is a fair argument. Except you forgot to realize that because Polaris is not that size and is not that far away, that's not a very valid argument. Because look, that's not what we observe in real life. Now, I'm going to draw what we would observe in real life. Okay, for the sake of scale, that dot is Earth. Okay? Now, that dot has this direction as south. And south, if Polaris is up there, we are not going to see Polaris if we are looking up in the southern hemisphere, which is true to our observations, whether we are on a flat disk or a globe. Now, what you say is not true to our observations is if that is the size of Polaris, right? That is Polaris there. Sorry, I have to keep on capping and uncapping my pens. So that is Polaris. If we look south, we are not going to see Polaris. Okay? If we look north, yeah, of course we're going to see Polaris. Now, no matter what point we are on Earth and we are looking north, as long as Polaris is not blocked by the bulge of the Earth, if you look north, you're going to see Polaris. Okay, that's me trying to draw straight lines. I'm kind of bad at it. And I should have used like a photo editor, but yeah, anyway. If you draw a line, Polaris is definitely in your line of sight. If you draw a line, you don't have to look towards Polaris because Polaris is far bigger than the Earth and not smaller.